Let's see a practical example of using observables in Angular 2. Here's the application I'll build. We start at today's date. Then you can use the two buttons here to go back and forth in the days with the 3 dates on the buttons and in the middle here, changing accordingly. And each time we'll load a weather report asynchronously and display that for that date. So here's the current markup. Instead of the dates, it just says today, next, and previous day. So to display the actual date we're currently looking at, I'll bind here to a current date observable. In the same way, we want to bind to previous and next date observables on the buttons. But we actually want to bind to what those observables will emit, not the observable objects themselves. So let's pipe all 3 observables through Angular's built-in async pipe, and anytime those observables emit a new value, the binding will be equal to that emitted value. Now, because we will emit date objects, let's pipe that one more time through the date pipe, which will display a long date string. Okay, let's create those observables. Now, the important part here is to identify that the only source of changes is when we click on the previous or next buttons. When that happens, we will trigger a change in the day. And so let's create day change, and that'll be a subject which will emit numbers, actually just +1 for next and -1 for previous. At this stage, just think of a subject as an event emitter. You can subscribe to it like any observable, and you can use its next method to emit a value. Now, how do we link the +1s and -1s that are being emitted to the current day we're looking at? Well, we start by showing today, so the offset starts from 0, and then it can be calculated simply by adding the current value to what the subject emitted. So here, if we click on the next button, the day change will emit 1, and the offset would be 0 + 1, which gives us 1. Then if we receive -1 from the previous button, it'll be back to 0. Another -1 would give us -1, then -2, and so on. There's an operator for this in RxJS called scan. Let's declare days from today, and that's equal to dayChange.scan, and here it receives the old and the new value, and we just need to return old plus new value. Also, let's pass 0 as a seed. That's our starting point. So with this, we have an observable that emits a number equal to the offset of days that we are looking at. Now we need to link that to a date or a moment object. When you simply want to transform one stream of numbers into a stream of dates, you can use a map operator. So current date is equal to daysfromtoday.map. We receive the offset from today as a number, let's call it n, and we return a moment object with n days added to it. The previous and next dates are similar, but instead of starting from the offset, I'll just say that they are always equal to the current date, with 1 day subtracted to get the previous date and 1 day added for the next date. So you can see that day changes is our only source of change, and everything else is simply related to that source via operators. Now in the template, let's trigger the change when the buttons are clicked, dayChange.next, and we emit either 1 for next or -1 for previous. One last thing, as the component gets loaded, no day change is yet emitted, so nothing would display. So in the afterViewInit lifecycle hook, we use this.dayChange.next, and we'll pass 0 to get started on today's date. Let's see that in the browser. Today's date is displayed, tomorrow and yesterday shows on the buttons, and as we click, all the dates follow accordingly. Let's work on the asynchronous data loading now. You can have a look at the weather data service and see that load data takes a moment object and returns an observable which completes with weather data after a random time between 0 and 3 seconds. That's just a way of simulating an API call. So back to the template, I'll replace the 32 with weather data, that's the observable we'll create in a second, pipe it into async, and then it will have a temperature property. To avoid problems with null values, I'll use Angular's Elvis operator by adding this question mark here. So while the output of weather data observable is null, this whole thing will just be ignored. Let's quickly do the same on the rain check and on the description, which is just going to contain the date as a proof that we're displaying the correct data. Okay, so how do we link the current date to the actual asynchronously loaded weather data? When mapping to the outcome of an async process, whether an observable or a promise, we can use flatMap. So weather data is current date.flatMap. Here we receive the moment object, and let's return this.weatherData, that's the name of the service we dependency injected here, .load data, and pass the moment object m. Here's what flatMap does. It subscribes to an observable that emits asynchronous processes, and in turn it emits what these processes themselves have emitted, in our case the weather data. Let's look at this in the browser. You can see the logs when data is being loaded, and when it stops loading, it gets displayed in the view. Two more considerations. You can see that we're loading data 3 times, one for each time we applied async to weather data in the template. That's because the observables are called, and each async creates a subscription, which in turn causes a new copy to be created. You can avoid that by using .share on the weather data definition, and now the observable is hot, and all subscriptions share the same data flow. You see only one console log for each request now. Alright, a last issue. Let me click very quickly on the previous button, and you see the requests being started in sequence. But since we randomize the API response time, they come back in a different order. And at the end, it's the last response that is displayed, not the last query. You can see what happens illustrated here with the flatMap operator. A very simple way to fix this is to use switchMap, which is similar to flatMap, except that it ignores previous observables as soon as a new one was emitted. So here, as soon as we issue a query for the orange value, even though the request still completes for green, switchMap will not emit the green results anymore. It'll only emit from the last query. So if we change to switchMap, you can see what happens here in the browser console. Even though data still comes in for the 18th July query, in-app, meaning after the switchMap operator, we only see the data for the last query, the 17th of July. So this shows some of the things you can do with observables. We started from a single source, namely the +1 and -1 emitted as we click on the next and previous buttons, and every other moving part in the application is automatically updated by defining their relationships to that source. Using async allows us to do that without explicitly having to subscribe to the observables, and it also takes care of unsubscribing when the component is destroyed.